Welcome. Here I would just like to do a summary of the different parameters we'll learn to estimate using sample statistics. So let's talk about the mean of a population. So if we don't collect data from an entire population, but we would like to know the mean, so mu would be our unknown population mean. Our best point estimate for it would be its corresponding statistic, which would be the mean of the sample, so the sample mean. And then variance, we haven't dealt with much so far, but the symbol for population variance, measuring variation in a data set, is sigma squared. So if we don't collect data from the entire population, the best estimate for it is the sample variance, so that's S squared. Standard deviation, previous to this chapter, we were often given sigma, population standard deviation, but here we're actually going to learn to estimate it, and our best point estimate would be the sample standard deviation. So that is lowercase s. And then finally, we'll learn to estimate unknown population proportions. So for example, what proportion of Americans feel we should have stricter gun control laws? So the proportion for the population, in my example, all Americans, so that would be P, lowercase p. And if we rely on a sample, so our best estimate for that population proportion is a new symbol for us. It's P, and it's a character on top. It's called P hat. And we'll get to that in a future section. All right, so moving forward here, symbols matter a lot. So I'm just repeating some of what I have here. So population mean is mu. And the sample mean is X bar. Now, population standard deviation is what we've been writing in the previous chapter. We were always given that value, and that was our sigma. But moving forward, it will be important that when we see standard deviation, we ask ourselves, is it the population standard deviation or just for a sample, a subset of the population? So sample standard deviation is our S. So every time we see standard deviation, we don't always want to write sigma. We need to ask ourselves which of these two it is. And you'll see why that's so important as we move forward. All right, so we're going to start though with estimating means. And let's take a look at the confidence interval then. So a confidence interval for an unknown population mean is always symmetric about its point estimate. So on my picture here, the point estimate for mu will be X bar. So we'll find the sample mean. And then the confidence interval will be that range of values with a lower and an upper limit. So I'm just going to write L for the lower limit and UL for the upper limit. So every range of values, the confidence interval will have an associated margin of error. So the margin of error is the distance from the point estimate to the limits. So I'm just going to write E here for margin of error. And then we'll go through the two different ways to express confidence interval. All right, so number one, based on a random sample of 200 American families of 2, a researcher estimates with 90% confidence that the true population mean amount spent on groceries per week for all American families of 2 is between $82 and $90. All right, so the population, all American families, you're not going to be able to collect data from all of them. So the researcher is using a sample of 200. All right, so when we see a confidence interval written with between, that means that they're giving us the lower limit and the upper limit of the confidence interval. So I'm just going to draw that here on my graph, on my number line. So 82 is the lower limit, $90 is the upper limit. So the form they've given, and we'll write it in this form then. So $82. We don't have to write units here. We'll just write the 82 and then less than. And then mu, the mean for all American families, and then less than, and then the upper limit. All right, so that was our given form. I'm going to repeat the 82 on my picture and then 90. All right, we are going to switch it into the second form, which is where we give our point estimate plus or minus the margin of error. So we're going to find the point estimate and the margin of error. And there are different ways to find these. I'm going to step through these formulas. So let me switch here to our second form. All right, so if we want to find X bar, the point estimate, it's in the center of the interval. So if we average the lower and upper limits, so if we take the lower limit plus the upper limit and divide that by 2, that will tell me where the center of that interval is. So 82 plus 90. So our numerator there is 172. Divide that by 2, and that is 86. And that visually looks good. We're right in the center of that distribution. So that's our sample mean, our point estimate 86. And then this formula will give you your margin of error. So remember that between the sample mean and the lower and upper limit, that distance is E. So the entire length of an interval, I'm going to draw it on my interval up here. That entire interval has a length of 2E, 2 margin of error. So if we knew how long the interval was, it's called the width of the interval. If I divide it by 2, I'll get my margin of error. So this formula will say, we'll take the upper limit minus the lower limit. That's the width of the interval. And divide that by 2 to get our margin of error. All right, so that will be 8 divided by 2. We have a margin of error of 4. So on my picture here, I'm just going to try to write it here. So E, that is 4, and that distance is 4. All right, now the formula works just fine, but I also just want to point out there would have been another way to find that value. So if we know that the point estimate is 86 and the upper limit is 90, 90 minus 86 is indeed 4. And 86 minus 82 is indeed 4. So different ways to find the value, and then we're ready to write the second form. All right, so in the second form, we say the parameter mu is, we write our point estimate, 86, so our center of the distribution, plus or minus our margin of error. And then we'll write that as a sentence. All right, so based on a sample of 200 families, a researcher estimates with 90% confidence that the true mean amount spent on groceries per week for all American families of 2 is, so rather than saying is between, now we say it is 86, and now we need our units in our sentences. So $86, and then accurate to within, so that word within will always refer to our margin of error, the plus or minus aspect. So they think it's $86, accurate to within $4. And we don't usually write the plus or minus in front here, but you'll see it written that way sometimes. So you're welcome to put the plus minus in as a reminder if you would like, but within does mean plus or minus. Okay, so that's how we go from the form lower limit, upper limit to the second form where we have the point estimate plus or minus the margin of error. And then let's go the other direction. So let's see how we start with the other form first. All right, so based on a random sample of 90 trees in a large apple orchard, the owner estimates with 95% confidence that the mean number of apples per tree for the population of trees in the orchard is 525, accurate to within 10 apples. Okay, so the confidence level in this one is 95%. So we'll learn once we start creating our own intervals that will take into account our confidence. And then let's write this form. So now they say is a value and then accurate to within. So now they're giving us the form mu. So based on the sample of 90 trees, this is what I think is true for the entire orchard of trees. We think that the mean is 525 apples per tree, plus or minus the within part, plus or minus 10 apples. All right, so let's draw this information. So the 525, that was the X bar value, the sample mean. So when they say is, where they got this value from is your sample mean, and then plus or minus 10. So they're giving us the margin of error. So let's go ahead and find the lower limit and the upper limit. So in this case, then, if we want to find the lower limit, we just take our point estimate and subtract our margin of error. So 515. And for the upper limit, we just take our point estimate and add our margin of error. And that will bring me up to 535. So on my picture there, 515 to 535. And then I'll put the margin of error on the picture. So this distance always gets a little squished here. That distance is 10. So 525 to 515 is 10, and 525 up to 535 is your margin of error, 10. Okay, so our second form then. So rather than saying we think the mean is 525, accurate to within 10 apples, we could have said we believe that lower limit 515 less than mu, the population mean, and then upper limit 535. So notice here when I create the confidence interval, creating it is based on the sample mean as the point estimate. But when you write your answer, it's always the entire population that we are trying to find the mean regarding. So mu here for the answer for the confidence interval. So our sentence now would be the same start based on these 90 trees. The owner estimates with 95% confidence that the true mean number of apples per tree for all of the trees in the orchard is somewhere between 515 and 535 apples. So to wrap this up, our whole process of confidence intervals is to say we don't want to go to every single tree in the orchard. It says it's a large orchard, so that seems unrealistic. But based on these 90 trees, we have a certain level of confidence that we know where the true mean for the population lies. So it could be completely wrong. Maybe it's not a mean between 515 and 535. All we know is that if we do this process of collecting sample data from 90 trees, that 95% of the time you do a study like this, you will find a confidence interval that contains the mean. Okay, so this shows you how to go back and forth between the two forms of the confidence interval. And then our next step is to learn how to create the confidence interval ourselves.